Hello everyone. Welcome to the solution of LeetCode problem 190 named triangle. In this problem, we are given a triangle array and we have to return the minimum path sum from top to bottom. We can go to the adjacent number of the row below in each step. More formally, if currently we are on the index I on the current row, then in one move, you can move to either index I or index I plus 1 on the next row. Suppose let's understand the first example. Here, it is the given triangle. In the first row, it has the value of 2. So as we have to find the minimum path sum, so from 2, we can go either this value 3 or this value 4. So we are going to 3. So currently we are at the position 3. Now from 3, we can go either 6 or 5. So as we have to find the minimum, then we have to go 5. Now from 5, we can go either 1 or either 8. We will go to 1 because of the minimum condition. So the total sum will be 2 plus 3 plus 5 plus 1, which is 11. So in this case, we have to return 11, which is the minimum path sum from top to bottom. Now, for this second triangle, it is given only one element. So that's why minus 10 is the expected output. Now, the constraint are the triangle length can be in between 1 to 200. And the first row length of this triangle is equal to 1. And each of the element presented in the triangle can be in between minus 10 to the power 4 to plus 10 to the power 4. I hope you understood the problem statement and the constraint as well as the examples. Now let's move on to the solution. Now, to solve this problem, we have taken the first example. The first row of this first example have the value 2. The second row has 3 and 4. The third row has 6, 5, and 7. And the fourth row has 4, 1, 8, and 3. So we have to find the minimum number of cost from top position row to the bottom row. So here, at first, we have to take 2. Now, for the row element 2, for the next step, we can take either 3 or 4. So as we are considering the minimal sum, so we have to take 3. Now from 3, we can either take 6 or 5. So here we have to take 5 for the minimal conditions. Now from 5, we can either take 1 or 8. So here we will take 1. So total summation will be 2 plus 3 plus 5 plus 1, which is 11. So in this case, the output is 11. Now at first, try to understand in which category this program basically belongs to. This program basically belongs to the dynamic programming category. Why? At first, for a problem to be categorized in dynamic programming, it should have 2 or 3 criteria. That means the problem should have some of the subproblems and it should have some of the overlapping subproblem, and after that, it should have some of the base cases. So first, try to understand what is the subproblem of this problem. Suppose currently we are at this top position, which is 2. Now, our problem is what is the minimal number of cost we have to pay if we want to reach the bottom row from this top row. So now, suppose in the next move, currently we are in this cell. The value is 3. So now our problem is, what is the minimum number of cost we have to pay if we want to reach the bottom row from these 3? Previously, our problem was we have to reach into the bottom row from the top element 3. Now our problem is we have to find the minimum number of amount we can pay if we want to reach the bottom row from this subordinate element 3. So it is a sub problem, right? Now try to understand if this problem has some overlapping sub problem or not. Suppose currently we are in this top position 2, and from 2 we can either go this value 3 or this value 4. And suppose we are currently presented in the value 3. So from this 3, we can go either this 6 or this 5. Now, when we are presented in these 3, our problem was what is the minimum number of cost we can reach from these 3 to the last row. But when suppose we reach in this 5, then our problem is what is the minimum number of cost we can reach from this 5 to the last row. So it is a sub-problem. Now, suppose currently we are presented in this cell 4. Now from this 4, we have two choices. Either I can go to 7 or I can go to 5. Suppose we are currently in the position 5. Now our problem is what is the minimum number of cost we can reach from this 5 to the last row. But wait, we have encountered this sub-problem before. When we reach this 5 from these 3, our sub-problem was in what is the minimum number of cost we have to pay if we want to reach the bottom row from this 5. Now, when we again reach this middle 5 element from this 4, our problem reduced into same sub-problem, which is what is the minimum number of cost we have to pay if we want to reach the bottom row from this 5. So we can say that this problem has some overlapping sub-problem. So till now, we have found that this problem has sub-problem and this problem has some overlapping sub-problem. So two of the criteria for a program or a problem to be categorized in dynamic programming is found. Now let's see. How can we find the base condition of this problem? Now, suppose currently we are presented in the last row. Suppose currently we are presented into this last element 4. So what is the minimum number of amount we have to pay if we want to reach the bottom row, which is exactly equal to 4. And if we currently present in this 1, we have to pay the amount of 1 to reach the bottom row. And currently, if we presented in this 8, we have to pay the amount of 8 if we reach the bottom row from this cell. And currently, if we presented in this element 3, we have to pay the 3 amount of money if we want to reach into this last row. Now, this is the base condition. So we have found the base conditions and we will solve this problem by using bottom-up TP. The algorithm is bottom-up. Now, currently, we have completed the iteration of this base conditions. Now, we are at this level. Now, suppose currently we are presented in this element 6. So the amount of money we have to pay if we want to reach to this last row from this 6 element is minimum of 6 plus 4 and 6 plus 1, which is minimum of 10 and 7. So here we have to pay the minimum amount of 7 to reach to the bottom row from this 6, which is 6 plus 1, 7. Now, suppose we are at this 5 element, and the minimum amount of money we have to pay, which is minimum of 5 plus 1 and 5 plus 8. Where 5 plus 1 is 6 and 5 plus 8 is 13. So minimum of 6 and 13 will be 6. So here we have to replace the 5 with the 6. Now suppose we are at this element 7 and we have to find the minimum cost to reach the bottom row from this 7. So here the answer will be 7 plus 8 and 7 plus 3 and their minimum. So here if we go this path, the summation will be 15, and if we go this path, the summation will be 10. So we have to find the minimum of 15 and 10, which is obviously 10. So we have to discard 7 here and replace it with the value 10. Now we are in this row. Currently we are presented into this element 3, and if we want to reach the bottom position from this 3, we have to pay the minimum of 3 plus 7 and 3 plus 6, where 3 plus 7 is 10 and 3 plus 6 is 9. So here the minimum is 9. So we have to replace the value 3 by 9. Suppose we are currently presented at this element, and if we want to go to the bottom positions, that means we have to pay 4 plus 6 and the minimum of 4 plus 10, which is 4 plus 6 is equal to 10 and 4 plus 10 is equal to 14. So the minimum is 10. So we have to pay the 10 amount of money and we have to replace 4 by 10. Now, currently we are in the top positions too. And from here, we can take either this path or this path. If we take the left path, the summation will be 2 plus 9. And if I take the right path, the summation will be 2 plus 10. So now we have to find the minimum, which is the minimum of 11 and 12. That means we have to replace 2 by 11. So here we can say that 11 amount of money we have to pay if we want to reach from the top positions to the bottom positions by giving the minimum amount of cost. So this is the basic strategy of bottom-up DP. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named minimum total. Then the input parameter is a vector of vector. And at first, we have to calculate the size of the vector. Now, we are using two for loop from the second last element to the first row. And in each of the iteration, for each of a of ij, we have to replace a of ij with the value of a of ij plus minimum of the next two element, which is a of I plus 1j plus 1 and a of I plus 1j. And finally, we have to return the first element of this two-dimensional vector, which is a of 0, 0. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n square because we have to iterate each of the cell of this two-dimensional vector. So in the worst case, the time complexity is big O of n square. And the space complexity is also big O of n square because we are using the input vector, and in the worst case, the size of this input vector can be n square. I hope you understood the time and space complexity analysis of this program. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.